Okay, so we're on example 6 now, and we're going to keep on graphing rational functions. We're going to follow the same steps as before, the same steps. So we're going to start with number 1. We're going to find their symmetry. And here I'm going to go ahead and they messed up and they didn't put the f there, so it should be f of x right here. Okay, so hopefully in the new edition they'll put the f in there, but if you're watching this video now and you have the old edition, there should be an f of x there. Anyway, symmetry, we're going to go ahead and put in the negative x and see what happens. End up getting 3, and this becomes x squared, and this is x squared. So I end up with the same thing here and here, which means I have y-axis symmetry. That becomes important in this problem because it'll save us some time now that we know that. 2 and find the y-intercept, and so I have f of 0 equals 3 times 0 squared over 0 squared minus 4, which gives me 0 over negative 4, which is 0. 0, 0 is my y-intercept. My x-intercept, set the numerator equals 0. Divide that by 3. Okay, x squared equals 0, x equals plus or minus 0, oops, or plus or minus square root of 0. So x equals plus or minus 0, which means x equals 0. So 0, 0 is my x-intercept. Shouldn't surprise us because that was my y-intercept too. Fourth thing I want to do is find if I have a vertical asymptote. We know that x squared minus 4 cannot equal 0. So x cannot equal negative 2 or 2. That means x equals negative 2 and x equals 2 are my horizontal asymptote. I mean vertical asymptotes. These are going to be dashed lines. In my horizontal asymptote, I'm going to go ahead and look at the degree. Degree of 2 and 2 here are the same. That means I'm going to do 3 over 1. So it's going to be y equals 3 over 1 or y equals 3. That can be a dashed line too. Okay. Again, I'm not going to go ahead and do the next step yet. I'm going to go ahead and step 5. I'm going to go ahead and just do all I know right now. I'm going to plot what I know, and then I'm going to come up with other ordered pairs to help me finish out my graph. So I know that 0, 0 is my intercept for x and y. And I have an x equals negative 2. Do some different color so we can see a little better. So again, I have 0, 0, and x equals negative 2, and x equals 2 are my vertical asymptotes, and y equals 3 is my horizontal asymptote. Okay, that's all I have so far. So all I have is a point here and these asymptotes. I need a lot of extra help to give me the rest of the graphs. That's why it's important to make a table or figure out some extra points. So I'm going to go ahead and do that and pick some values out for x and figure out what y would have to be. So I'm going to go ahead and I'm going to go ahead and find some values over here. I'm going to do negative 3, negative 4, and do negative 5. This is going on over here. Okay? So negative 3, negative 4, and negative 5. That'll give me here 9 times 3, which is 27. I get 27. This will give me 9 minus 4, which is 5. So 27 over 5, which will give me 5.4. If you can read my handwriting there, that'll make it a little bit bigger. So I get negative 3 and 5.4. F of negative 4 is going to be 3 times negative 4 squared all over negative 4 squared minus 4. I get 16 times 3, which is 48. And here I get 16 minus 4, which is 12, which gives me 4. So I get negative 4, 4. And then I do f of negative 5. Okay, that'll give me 25 times 3, which is 75. Give me 25 minus 4, which is 21. And put my calculator right here, so 75 divided by 21 is approximately 3.6. So negative 5 and 3.6. So I know what's going on up here. Let's see what's happening at negative 1. Negative 1, I'm going to go ahead and tell you that I get negative 1, I get, let's go do this one. Negative 1, I get f of negative 1, which is 3 times negative 1 squared, all over negative 1 squared minus 4. This gives me 1 times 3, which is 3. Gives me 1 minus 4, which is negative 3, so I get negative 1. Okay. Here where, if you know you have symmetry, life is going to be nice to you. So let's go ahead and plot these points real quick, and I'll do in purple. Negative 3 and 5.4 about right here. Negative 4 and 4 will be right here. And negative 5 and 3.6 will be right about here. Now, the asymptotes tell me that these are going to go on forever but never touch and never reach across these asymptotes. I know that negative 1 is the point. So here's that point right here. Because there's y-axis symmetry, we established in the beginning that there's y-axis symmetry. That means I know that these points are all going to be symmetrical across the y-axis. So this point should be symmetrical right here. So I know I can do that. And if you really want to, you could plug in 1 right here. If you do that, you'll get the point 1, negative 1 anyway. This gives me this part of the graph now. And again, this is symmetrical, and at this point, it's going to be the exact same point on this side right here. So it's going to be 4, 4. Not the exact same point, but it can be symmetrical. So 4, 4. The point can be symmetrical here also. So I'm going to go ahead and put it right there. So it was negative 3, 5.4. Now it's 3 and 5.4. And then this point right here. If you don't believe me, go ahead and plug in 3, 4, and 5 down on this table here, and you'll get the same y value. So that's why it's helpful to have y-axis symmetry. If you know you have y-axis symmetry, then it's really helpful to go ahead and plot those other points there. Okay? So now go ahead on the next problem on your own. Go ahead and do the same thing, and I went ahead and started doing it to save myself time. But on your own, go do the next problem, and on top page 142, and then go ahead and pause the video, and then check your answers when you get done. Okay, so on your own problem, I went ahead and found that there is y-axis symmetry, and my y-intercept was 0, 0, my x-intercept was 0, 0. My vertical asymptote was x equals negative 3 and x equals 3. And the horizontal asymptote is y equals 2. And so at that point, I went ahead and, before I made the points up, I'm going to go ahead and plot right now. So I have 0, 0 as my x and y intercept. I have x equals negative 3, with a dashed line. And x equals 3 as my my vertical asymptote to x equals negative 3 and x equals 3. These are my vertical asymptotes. The horizontal asymptote is y equals 2. Okay. And so I came up with points, and I did, this time I did the positive values. So I did 1 and then 0.25, 1 and negative 0.25, which is about there. 2 and negative 1.6 right there. 4 and 4.6. 1, 2, 3, 4, 6. 5 and 3.125. And let's do one more, let's do 6. And so I do 6, I get 72 over 27, which is about 2.7. So I get 6 and 2.7. So 1, 2, 3, 4, 5, 6, 1, 2.7. So I kind of get this graph right here. I get this graph right here. Again, since we have y symmetry, I can go ahead and reflect on my points across the y-axis. And here I would have, I had 1, 2, 3, 4, 5, and 3.125. And I do negative 5. 1, 2, 3, 4, 2, 5 right there. And I have negative 4 and 4.6. And negative 6 and 2.7. So instead of plugging in all the negative values in my table, I don't have to do that because I know I have y-axis symmetry. Okay. I don't think I'm going to have time to finish these next two examples in this 15-minute time allotment I have, so I'm going to go ahead and stop the video here. And we'll do the example 7 and example and on your own in the next video. It'll be a short video.